Hello guys, my name is Henry. So I decided to make this video because of what I noticed in the group. I'm also a PC 103 student. So I noticed the group for the computer programming class course is I saw some messages from people. Some people seem to be very confused. A lot of people seems to be finding it very difficult, to understand or get understand what to do to solve these challenges. Number one, I want to make something clear that the ultimate goal of this course is not actually to make you write code or memorize code. It's actually to make you to develop the ability to think like a programmer. Okay. So a while back, when I was learning how to program, there's a particular concept in computer science that really helped me, to become better in programming. It's called pseudocode. Pseudocode is not machine readable. A pseudocode is something that is only human readable, so it cannot be executed by the system or by the compiler, language compiler or language interpreter. It is meant for human to read. So according to this Google definition, in computer science, pseudocode is a plain language description of the steps in an algorithm or another system. Pseudocode often uses structural conventions of a normal programming language, but is intended for human reading rather than machine reading. So pseudocode, what it does is that it helps you to write the steps that your code needs to go through in order to achieve a task, the task that you want to do. Let's say, for example, you want to make a cake. Okay, you want to make a cake. Now, some of the convention of pseudocode involves, when you want to start the first line, you should write start. That's the starting point of your program. Then when you finish, you should write end. That's or stop. That's the end of your program. So let's say we want to perform a task of making a cake. The first logical step to make a cake is to start the program. Okay, start, and the first step, you get the ingredients. So after getting the ingredients, the next thing you want to do is to mix the ingredients. Okay, so after mixing the ingredients, the next thing is to set an oven timer and put the cake inside the oven so that the cake can bake. All right, so after that, if the timer is done counting, you remove the cake, else continue baking until the timer is done counting. So, and this line sounds like a loop to me. So once the timer is done counting, the program will hit this part of the code, this else part of the code, and the program will end. So that's a simple illustration of a program that makes a cake. So now let's take another example. Now this time we are going to take an example of the one of the challenges we have this week, which is a number guessing, a program that generates a random number and tells the player to guess the number. Let's try and write the pseudocode. Now we know that. Let me clear this. The task. This is our task. Our task is number guessing game. We want to write a number guessing game. Okay. So the first step, start the program. Okay. So the next step is to generate a random number. Generate a random number. Okay, so the next logical step after generating a random number is to prompt the player to guess the number and store that number in a variable. So prompt player to guess a number and store the number in a variable. So after we do this, the next logical step, when we receive the number, the inputs from the player is going to come in form of a string. So we need to convert that number into integer type, because when we are comparing numbers, we can only compare number and number. You can't compare number and string and number data type, or integer and string data type. So we need to convert that number that the player has imputed to integer data type. So convert number to int data type. Okay, so after we do this, the next thing that we should do is to now compare that number, the guessed number, with the computer generated number. So compare the guessed number, that is the number that the player imputed, guessed number, against the computer generated number. Okay, so after we do this, if the guessed number is equal, we check if they are the same thing with the if the guessed number is the same thing with the generated number, then that means the player guessed it right. So we congratulate the player and end the game. Okay, so if guessed number is equal to computer generated number, congratulate the user and break the loop. Congratulate the user, break the loop, and end the game. Okay, otherwise, if guess number is higher, we check if the guess number is higher. What do we want to do? If the guess number is higher, if the guessed number is higher, or let me use this sign, is greater than computer generated number, then we give the player a feedback that the number provided is too high. Provide feedback and continue the loop and restart the loop again, so that the player can guess another number again. So that means then loop back, loop, and restart loop, okay, so we restart loop. That means our program will go back to line 7 here, because if we restart from the start, that means the system is going to generate a new number, but we don't want to do that. We want to restart the loop. We are not restarting the whole program, we want to restart the loop. We just tell the player to guess the number, so it will still be the same number that the program generated initially, that the player is still going to try to be guessing. So the number is not changing until the program is terminated, until the program ends. So while the player keeps guessing, the loop will keep restarting from this line 7. Restart loop from line 7. Okay, start loop from line 7. So, and the same thing, if the guess number is less than the computer generated number, you also provide feedback to tell the player that the number provided is too low. So then the program restarts the loop again from line 7 again. So that's how the program is going to run until the player eventually gets it right. So if the player gets the number right, the program will terminate at this line 10, which says if guess number is equal to generated number, congratulate the user, break the loop, and end the game. So that is the end of our pseudocode. You can see writing pseudocodes forces you to think about how your program is going to run, and it makes you to avoid unnecessary beating around the bush or writing an unnecessary code that you don't need to write, and it reduces the time you are going to spend on your VS Code. You can even write these VS codes on a piece of paper, or even on your notepad, whether on your phone or even on the computer, before you eventually open your VS Code or any other IDE you are using, before you start writing the actual code that the computer will execute. So this is one tip that will help you, going forward, to when you practice. It takes practice. So when you practice doing this, it will, with time, you will start, learning how to think like a programmer and actually think the way the computer thinks too. So thank you. Depending on the number of likes I get from this video, if I get at least 10 people to like this video, I will do a pseudocode for the word puzzle game and try to explain each steps. Thank you and remain blessed.